Flack math! Give me some math and I'll give you some flack. Flack math!
We are going to apply trigonometry to calculate angles of elevation and depression. Okay, so let's just start with an example. Let's say that we've got a person here. And what we're doing, this person is looking up to here. Here is a pretty little bird. I don't know how to draw a bird.
I know how to draw a bird.
That looks like a bird. Okay. So what we have here is technically this angle is called the angle of elevation. Okay. Are we talking about hair?
Yeah, sorry.
No, we're talking about math.
Yeah.
Hey, you can talk about hair and math at the same time.
Yeah. It's like counting them on a hair.
Hair. If you talk about hair, that's offensive to me. I don't believe in hair.
Just grow
Okay.
more.
So this guy, if the bird was looking down at the dude, this is the angle of depression. Hey, stop talking about hair.
I'm telling you my hair.
So
I'm
insensitive.
asking for a pencil.
I do.
Okay. I was talking about hair.
Okay.
Okay, thank you.
So what can you tell me about the angle of elevation and the angle of depression?
It's acute.
They are acute in this case, yes?
What?
They're equal. 'Cause
Congruent.
they're congruent or equal measures. Good. So they're because they're alternate interior angles of parallel lines, right?
I actually thought I was wrong.
Okay. So listen carefully. Ready? That means don't be on your phone.
Sorry.
Sorry means I'm sorry that I did that, and I promise to never ever do that again in your class.
I will.
I hate the words I'm sorry.
Sorry. All right, you don't have
No,
to.
you're not. Then why'd you do it? Sorry.
You can do something wrong and say sorry, but every time you apologize, you're making a promise.
Is
I'm sorry. That means I will try my hardest to never do that again.
I need to try.
Otherwise, just don't say sorry. I'm like, okay. You can just say, I kind of feel bad about that.
Or you could be like, oh, why?
Just say oof.
What if it's something a bad situation? You're like, oh, I'm so sorry about that. And they're like, that's a stupid reason to say sorry, kid. and it's like, no, it's not. I genuinely feel bad for you, and I hope that never happens.
So sorry, that's probably not, I mean, I say that all the time too.
Right?
But when you say sorry, it's like I hope that never happens again.
Yeah.
I'm quite
I hope
say
I never
sorry
get
without
caught again.
kind of regretting what
But
you
if
did.
someone says,
Yeah.
I'm sorry for you.
No, don't say sorry.
Why'd you mean it?
I mean, you can say it.
I mean, you can say,
I'm
I'm sorry.
Don't realize their tone.
say it like that because you're a poopy pants, but
Smush things
you know,
down to the point
whatever.
where it's like,
All right.
the lines.
Guys, listen very carefully. An angle of elevation is the angle formed by a horizontal line and the line of sight to a point above. In the diagram here, this angle 1 is the angle of elevation. Okay? All right, good. Angle of depression is the angle formed by a horizontal line and a line of sight to a point below. Okay? So it kind of depends on who the subject is and where they're looking. Okay? So what we're going to do is we are going to calculate, this is example 1. We are going to calculate this angle, well, we already know the angle of elevation. So let's say that we've got this angle of elevation here, and it is 36 degrees. Okay, so this person, angle of elevation is 36 degrees. Here's the bird. I don't know what the bird. I'm not good at birds. Okay, so here's the question. The angle of elevation between the kite. I guess it's a kite. And the child. I guess it's not a person. It's a child. Well, childs are persons. Maddie was just gave me a look of death right there. Goodness. I'm sorry. Childs are persons too. Children's. Okay. Use the angle of elevation between the kite and to find the horizontal distance between the kite and the child. So we're trying to find this distance. And let's say we know the length of the string of the kite. It is 80 feet. Well, how the heck do you find that distance? So how do you find that?
Wait.
You could a squared plus b squared equals c squared.
You could if you had an A or a B, but you only have C.
So
Wait, do you need all the angles, right?
you're finding the
We don't need them, but I mean, we could figure that out. What is that? 44 degrees or 50 or 54 degrees, right?
Yeah.
Okay.
But we already have the distance.
And then
Well, we want to know this distance.
I forgot the third one because we're trying to find adjacent,
wait,
right?
no, that's
Yeah.
We're finding adjacent. Opposite is
Okay.
the right leg. And I forgot the other name.
Okay. You're right. So this is opposite. This is adjacent.
Yeah.
So we're using trigonometry. So what's the acronym?
Oh, isn't it SOHCAHTOA?
Yep. SOHCAHTOA.
Yeah, I hate
So what's the S? What's the O and the H and the A and the H stand for?
Isn't it like, I know. I know this.
angle height.
Oh.
No.
No, it's
Opposite.
gross.
Wait, it's opposite adjacent hypotenuse?
Yep. So that's opposite.
Mhm.
That's hypotenuse.
And it's opposite over adjacent.
This is adjacent and hypotenuse. So you have to choose the one that has that what you're looking for and what you're given. So this is opposite, adjacent. So which one of these is going to be useful? The SO, the KA, or the TOA? So according to that angle, 36 degrees, what sides are you given and what you're looking for?
So it would be cosine.
Yeah, because look, according to 36, cosine of 36 degrees is going to be adjacent to 36. Remember, the adjacent side, if you don't have this memorized, you need to write it down. The adjacent side in a right triangle to an angle is whatever side that remember the angle has two sides, right? Two sides of an angle. It's whichever side is not the hypotenuse. Well, this is the hypotenuse. The longest side in a right triangle is always the hypotenuse. It's the diagonal side, whatever. Okay, so X is your adjacent side. And what does H stand for? Which is 80. Okay, so using trigonometry, if you're given an angle and one of the sides, you can use trigonometry to figure out everything else about that triangle, as long as it's the right triangle. Okay? So what's X? How do you find X? Well, cosine of 36.
Yeah.
Get rid of that 80, right? You're trying to get X by itself. So if you're dividing by 80, do the opposite, multiply by 80. So let's do that on the calculator. What's cosine of 36 times 80? Okay. So on a calculator, do you guys know how to find the cosine of 36? on a calculator?
Probably not.
That means you have either not done your homework or you're Googling it. So congratulations.
How do you do it?
So cosine of 36 degrees. You
I
need to
have a
know how to
little
find the cosine.
button that I put. That's all I do.
That's great. That works. So cosine of 36 times 80. What do you get?
Yeah.
Should get about 64.72. Is that what you got?
One second.
Is that what you got? Is that what you got?
Wait, hold up. What was I saying?
Are we there yet? Are we there yet?
Hold up. $64.72.
All right. Good. Awesome. Okay, so this is basic trigonometry. This is as basic as it gets. You can do this stuff. You just have to remember these ratios. So sine equals the opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Oops. Tangent equals opposite over adjacent. Okay? So remembering those is one trick. I mean, that's kind of tricky, but you have to remember those. On a test, I mean, do you really have to remember those? No. I'm going to let you use that acronym, okay? So just make sure you know how to identify relative to the angle, which one is the opposite of the angle? Cross the pond of the angle, right? Which one is the adjacent one? Whichever side of the angle is not the hypotenuse. And then the hypotenuse. You guys should be able to recognize the hypotenuse in any right triangle, right? Okay, so that guy never changes. The hypotenuse never changes. The adjacent and opposite are relative to what angle you're talking about. So how would you calculate the sine of 54 degrees? How would you calculate x using this? Because there's more than one way to do this problem. So what's the sine of 54 degrees equal to? Not on a calculator, because that's a constant, but what would your equation be in this problem? Sine of 54 equals what over what?
Opposite of hypotenuse.
Uh-huh. So what's opposite of 54 degrees?
36. No.
What's side? So
Oh.
x, and what's hypotenuse? 80. So sine of 54 degrees equals x over 80. So if you guys didn't realize this already, the cosine of one of the angles is the same thing as the sine of the other angle in that right triangle. They're complementary. Okay. So angle of depression, same kind of thing. If you got an airplane up here, here's example 2. Here's an airplane. I don't want to waste my life with drawing, so that's what you're gonna get, okay? So let's say it looks like the airplane is crashing. It's not, okay? So there's a lake here. It's not crashing into the lake, okay? So don't think morbid thoughts. The pilot in a plane cruising at 33,000 feet, what does that mean? That means this number is 33,000 feet. Okay, 33,000 feet. Sees a lake. All right, the lake is obviously on the ground. If it's not, then you're not in
Are you
this
sure it's not in the
world.
sky?
It's not in the sky. It's not like Avatar, whatever. If the angle of depression from the plane to the lake is 30 degrees, so that means this guy right here. So this is 30 degrees. Okay? Then, how far is the plane from the lake? Okay? How far is this? So we want to know this distance. Okay? Can you guys figure that out? You can work with either this triangle or this triangle. Doesn't matter. You're gonna get the same
Because
answer.
they're congruent.
Yep. So see if you can figure that out on your calculators. Go, go.
Wait, I'll go. Which one did we use?
So let me just tell you that there's about 4 or 5 different ways you can do this.
One of them you can use tangent, right? Or am I just making that up?
Tangent? Yeah, you can use tangent.
Is that an 8 or a 0? Oh, that's it.
This one
Is
is
that
33,000 feet.
opposite over adjacent for tangent?
Yep. Tola.
Yeah. Okay. Let's see.
Okay, did you hear me say that there's like 4 or 5 different ways you could do this?
Okay.
And I'm seeing almost everybody doing this.
Do I get on my calculator?
What is the height of that?
Well, what does your gut tell you? This height, is this what you're talking about?
No, the other one. I can't read.
Oh, 33,000. So if this is 33,000, what's this?
I got a big
Depends on what
number.
triangle you're working on. You don't have to do, I mean, I see 2 triangles on the board. And remember in geometry, if it looks the same, it probably is.
Is it a big number?
Well, I would think so, because
Okay.
if this is 33,000, then that's going to be pretty big too.
Can it be bigger than 33?
No, yes, it will be.
Oh, I did it.
I didn't draw it perfectly, but it'll be bigger because it looks bigger, right?
Yeah. Okay.
But you're kind of relying on my drawing at this point.
So it's bigger. Okay. Ah, dang it.
So it all depends on the perspective, right? Like it doesn't have to be. It doesn't have to be the plane's angle of depression. We could be talking about the lake's angle of elevation. Okay? But either way, it doesn't matter how it's worded. Fill in the blanks. I would draw a diagram. Always draw a diagram because it helps you get your brain on the page so you can see what's happening.
I keep getting the number smaller than 33.
Yes, sir.
Is it 28,578?
That's what I got at one point.
Yeah.
8,
Whoa.
4.
Well, your classmates agree with you. Did anyone get something different?
I also
But it's
got
not the right answer. is what I'm asking.
Oh, ask your class.
I got a few different answers.
But that was one of them?
Yeah.
Were you just like trying it different ways?
I tried both with sin, code, and
Yep,
tangent.
good.
I tried them all.
Good. Why did you do that?
Because I wasn't liking any of my answers.
Good. That's a good strategy. So if there's 4 or 5 different ways to do the same math problem, which way are you going to do it on the test?
It is that number.
Which way are you going to do it on the test? If there's 4 or 5
The
different
one that
ways.
looks best after you keep trying.
Pick one that's the easiest to get.
1, 2, 3, 4, or 5. What if you do all 5?
Yes, that's the best way to do it. So
Yeah. I got
yeah,
it
that's a
different.
great way. If you get the same answer and you do them completely different ways, I mean, that's a pretty good sign that you did it
I
right.
got 3 different answers.
Did I get
Okay,
the right answer?
Tristan, let's walk me through it.
I did 30,000.
33,000.
33,000. Sorry. I did 33,000 times COS.
Okay, so what did you start with? So what did you do? You found the cosine of what?
I just 30.
COS of what? What was it after that? 33,000 times cosine of what?
Oh, I did 30.
Okay, so what is the cosine of 30 degrees? How do you calculate that?
0.8660254033784.
Well,
So you did the cosine of 30 degrees,
yeah.
which would be x over this unknown number here. Okay, so that doesn't really help us because we don't have x and we don't have that unknown number. Now I heard Tori say something a little bit earlier. How did you do it?
Wouldn't you find the opposite angle of 30, right? So
You could. I mean, if
So
you'd
you could
rather
do
work
50.
with that,
60.
right?
But I don't know. I just kind of, I did the 60 times the cosine. What am I doing? I did backwards. I did cosine of 60, which equals, 0.5. And then I multiplied that by the 33,000. But
So you could, if you're trying to find that distance, that would be what I would do. Because cosine equals adjacent
And then
over hypotenuse.
I tried tangent too.
Okay.
Tangent gave me a different one.
All right, I'm gonna do the tangent route. Because here's the deal.
Tangent was
Your-
the first one I did.
You're looking for one of the legs of this triangle and you're given one of the legs. So the legs are either opposite or adjacent. So which ratio uses opposite and adjacent? Well, none of these.
See, I used tangent first.
Okay, well, let's go with tangent. Tangent of what equals what over
I
what?
did tangent of 60 actually.
Okay, equals what over what?
Equals opposite over adjacent. So
Okay, so
30.
what's opposite of 60?
30.
What's
Oh.
opposite of the 60-degree angle?
X.
X. And what's adjacent to the 60-degree angle?
30.
33,000.
And then I just rearranged it.
Yep. So how'd you do that?
Got rid of the 80s, moved it over by canceling them out. I mean, not the 80s.
We did the 80s in the last problem.
Yeah. 33,000. So then it's 3. And then you add the little multiplier.
Okay, so do that on your calculator. Okay, so if you don't have a calculator, you can borrow one.
Answer.
If you're using your phone for a calculator, you can do that on homework and stuff, but not on a test.
I did.
Do you remember how to use the trigonometric functions on an iPhone?
Yeah, like you turn it over, right?
Yep.
Yeah, you make it horizontal, and there's a lot.
On mine, I just swipe it to the side.
This doesn't work because it didn't unlock it. So
I'm pretty sure you can just also, I don't have an iPhone, but most of the time you can just swipe it to the side too.
really? What? No, that doesn't work.
Is your screen locked?
Okay, what do you got? What's
I got-
33,000 times the tan of 60?
57,157.67.
57,100.
Well,
What?
technically, it would be
157.
68.
0.6, yeah, 68, but.
Okay,
67.
so, well, no, it's probably 6 repeating, isn't it?
No, it's
No.
6766497.
So we'll say 68, and then we'll change this equal sign to an approximation sign. Now, what does your gut tell you? Does that look like it might be right?
Yeah.
Yeah, it looks about right. If I drew this, I didn't draw it terribly. Okay, now
But
here's
I used tangent
the
first.
fun piece of information. I read the problem wrong, but
Oh,
now, how would you find y? Now,
Oh.
here's a hint.
36.
Cosine.
It's a 30-60 right triangle, so what's y? That's what they're really asking.
Oh, if it's a 30-60.
So what's the shortcut to find the hypotenuse in a 30-60 right triangle? Do you guys remember the shortcut? If you don't remember the shortcut, that's okay.
That radical 3.
So that would be what this would be. You could do the Pythagorean theorem if you wanted to square 33,000 and 57,157. If you wanted to do that, that's great, but there is a shortcut to a 30-60 right triangle. What is it?
Are you looking for y? Couldn't you just use cosine now?
You could.
That's what I did.
Now that you have x, you could use cosine, but don't do that. Take advantage of the nice 30-60 right triangle. What's the formula? What's the shortcut?
So not just radical 3? Isn't it?
One of them is radical 3. This is
Like
radical 3. That's radical 3.
Oh.
That's what we could have done here to find x. We should have recognized that this is a 30, 60 right triangle. Oh, you just multiply that by radical 3, right?
That is
All right, so what's this?
twice the short.
Twice the short leg. So what's y?
Twice.
Um,
66,000.
Wait, just kidding. That's incorrect.
Right, so that's what they actually asked us. Okay, but again,
That makes
we
sense.
did this. You guys just gave me like 4 or 5 suggestions on how to find 66,000. You wouldn't have gotten it wrong. You just would have wasted a little bit of your life, more than you had to. Okay, so that's fine. And sooner or later, your brain is going to force you to do shortcuts. Okay, your brain is going to get tired of, wait a minute, oh yeah, this is a 30, 60 right triangle. I could have just done this. Silly me, but you got it. That's fine. All right. On a standardized test, it's really nice to know these, right? Because these standardized tests, SATs, you got to know you're going to be timed, okay? So it's not enough to do math well. You got to do it well and fast. That's the world we live in, okay? So work on both. All right, should we do one more example, or do you guys feel like you got it?
Not great.
Okay, let's move on to lesson 74. Nobody's zooming in today.
Is there anyone that needs to do that?
Yeah.
You guys know Caden, don't you? Caden McCorkey?
Did you go here last year?
Oh,
Yeah.
what's he?
No.
His long hair thing? What grade is he? He's in ninth.
He's he kind of moved ahead because
Oh, was he in our math class? Yeah.
he's real mathy.
Oh, yeah.
I don't know. I took algebra 2 last year.
Was it our math class?
All right, we ready?
No,
I don't know this game.
Okay, so we talked about last week, or on Tuesday, we talked about transformations. We talked about one specific transformation. Do you remember what that was?
it was something with an R. Reflection.
That's actually what we're going to talk about today. What did we talk about on Tuesday?
Refraction? No.
It starts with a T.
Transversal?
Translation, that's right. Which doesn't, I don't like that word because it makes you think like you're translating another language. But it just means sliding something, right? But rotation kind of makes sense. You're rotating it. Reflection means you're flipping it, right? Translation is the only weird one that you have to remember. Doesn't really sound like what it is.
What's up with your hand?
Of this,
Yeah.
all the whiteboard does. This is way better
Yeah.
than like
That
an
was-
eraser.
No,
But
I
it
know.
makes my hand filthy.
I was gonna say, my first day in your class, you went on for like 10 minutes about how much you like the washcloth better than the.
What? 10 minutes? I wouldn't waste class time like that. That's silly.
Oh, I'm sorry, it was only like 10 seconds.
Yeah, 10 seconds.
She's got your back.
Was
it even that long?
It felt like forever.
Those kind of things are important though. So
I think it was just a screw.
one day you might be teaching and you're going to go a whole year with whiteboard poop on your whiteboard all year because you're not using the rag instead of the eraser. That's not whiteboard poop. That's I'm going to stop talking. Okay, so we're going to do reflection. So reflection is a transformation that reflects every point over a figure. So the best way to describe this is to just draw something. So if we have like a triangle right here, okay, and let's say we're going to reflect over the y-axis. So it's the same distance and the same location to its image, from the pre-image to its image. Not drawn great, but that's the idea, okay? So you're reflecting over a given line. So most of the time it's going to be over the y-axis or the x-axis. I could have done it over the x-axis, right? And I could have done the same kind of thing there. Boom, boom. So there's a reflection over the x-axis, and this is a reflection over the y-axis. They're both reflections. This depends on where you're going. This doesn't take much explanation. This unit is pretty self-explanatory. The only way you're going to mess this up is if you miscount or do something weird, okay? But that's basically it. So let me start with an example. And a lot of, on your tests and in your homework, you're probably going to have to draw these. So if you just kind of rough it out, it doesn't have to be exact. You don't have to take out a ruler and measure the distance and all that stuff. Just use your best guess and connect the dots, okay? So here's example 1. But on a test, be exact, okay? Because it's going to affect everything else, okay? So here is, for some reason, they did this, whatever. So here's one of my points is right here. So it looks like that's -2, 3 right there. And then I've got -7 and then 1. So this is -7, 1 right there. And then I've got -7, 6. Right there, this is -7, 6. So here's the cool thing. Let's say I'm going to reflect this over the y-axis. So you could probably guess, without even drawing it, where the image is going to take it. So this is the pre-image. So what's the image? So here's my transformation. The transformation is going to go from xy. And what are you going to do with the x's? What are you going to do with the x's? How are you going to draw this point? If it's reflected over the y-axis, how are you going to draw that? Where are you going to put it? Tobin?
Don't you just take away the negative? So
Yeah, you put it on the other side, so you're going to negate that. So this is going to be -x, but the same y, right? So if I go over to -7, and then at -1, so basically I changed the x value. I just changed the sign of the x value. I negated it by putting the negative sign in front of it. So now instead of -7, it's -7, which is just 7. So this is the mapping. You guys need to know how to do this. The transformation says, take your xy, and you're going to negate the x and leave the y alone. Okay? All right, so let's try. This is pretty easy because it's reflected over the y-axis. And it's really easy if it reflects over the x-axis. But what if it's reflected over just some random line? Let's try that. Let's try example 2, which is this. So I want to reflect this over y equals 4. I want to reflect that shape over y equals 4. I'm going to make this a little bit smaller.
Would you just negate it in the next one?
Well, let's see. Okay, so if this is U, V, S, and T. So let's say T is at, let's see, 2, comma, 8. So this would be 2, comma, 6. So this is negative 2, comma 6, and negative 2, comma 8. Okay? So I want to reflect it over 4. Y equals 4. So this is going up 2 units here. So if I drew in the, probably better to draw them in. So where's our new image going to be? Where is U prime going to be? Well, it looks like it's going to go about to right there. So there's U prime. So what's the coordinates of U prime? Two, comma, 2. So the X value didn't change. The only thing that changed was the Y value. So can I just subtract 4 from each one? Does that work?
Yes, right?
So what happens if where's my T prime going to be?
T prime should be negative 2.
Yeah.
Negative.
So look, how far is this from Y equals 4? So if this is Y equals 8, and this is Y equals 4, it is 4 units away. So this has got to be 4 units away. So this is going to be at 2, 0. So T prime is 2, comma 0. Okay. Now I graphed this wrong so that the rectangle is a little chubbier or taller than it should be. Okay. So yeah, so subtracting 4 doesn't work. All right, well, what about S prime? S prime is going to be at negative 2, comma 2. And then V prime is going to be negative 2, comma 0. So here is our reflected image. And again, I drew that wrong, so it doesn't look like a reflection. Yeah, so it should be, yeah. Ugh, that's terrible, terrible drawing, but whatever. Okay, so what does our mapping look like? What does our mapping look like? Well, let's see if we can figure that out. So it goes from XY, always starts with XY. But what happens to the X's?
Then
The X's stay the same.
X's stay the same. See, to go from 2 to 2, or 2 to 2 stays the same. These negative 2 stay the same. So the X's don't change. Well, what happens to the Y's?
negative 6.
So negative 6 doesn't really work because U prime, if you subtract 6 from 6, then you get 0. So that didn't work. What do you think?
I mean, so the first one is -4, the second one is -4, plus the difference. Or minus the difference. Wait, yeah, minus the difference.
Okay.
That makes sense.
What if this was at the origin? What if it was reflecting over this axis?
Wouldn't it just be the opposite?
Yeah, it would just be the opposite y. So let's start there. So what do you have to add to the opposite y to get your new value? Well, what do you have to add to the opposite of 6 to get 2? 8. What do you have to add to the opposite of 8 to get 0? 8. What do you have to add to the opposite of 6 to get 2? 8. Okay, so you're basically adding 8. So there is a part where you do have to negate it, but there's a shift where the line of reflection is. Okay. All right. So here's the deal. Here's the breakdown of when it's reflected across a line that's not the x-axis, but just a horizontal line. So the x value does not change. The x coordinate doesn't change. When a point is reflected across a vertical line, the y coordinate doesn't change. Okay? So to find the reflection of a point across any line in the coordinate plane, draw a perpendicular line from the point to the line of reflection. The point's reflection will be equidistant from the line of reflection on both sides. So you just kind of have to draw it out and figure it out. Okay? Draw it on a piece of graph paper. See how it pays to do it on graph paper, because this is horrible. All right?
Yeah, graph paper makes it look like that.
Okay, so this is nice because it's a horizontal line. It would be just as easy if it was a vertical line, right? But what if it's not? What if it's a different line? Well, let's start with the next easiest one. Besides a vertical or a horizontal line, let's start with just a perfectly 45-degree y equals x line. Okay? So here is example 3. So I want to reflect JKLM across y equals x. What does y equals x look like? Y equals x looks like this. Because on everywhere on this line, y equals x. So here's 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. So the x coordinate and the y coordinate are the same. So that line is y equals x. So I'm going to reflect this guy, which is so quadrilateral JKLM is -3, 5. Okay, so there's J. K is at 0, 8. So here's J. Here's K. L is at 3, 5. 1, 2, 3. 1, 2, 3, 4, 5. Here's L. And then M is at 0, 1. Okay? So I want to reflect it over here. Well, let's just do it. Let's just do it by hand. Let's just graph it. Okay, so if I do this, where's the reflection here? It looks like it's right there. So what's the coordinate there? Well, this is 0, 1. This is -3, 5. This is 3, 5. And this is 0, 8, right? 0, 8. So if I reflect it, this is going to be 1, 0. And then if I reflect this, let's see, it looks like it's going to, okay, and so instead of going over left -3 and up 5, it's probably going to go right 3 and down 5. So about right there. So that's -3, -5. No, +3, -5, right? Does that look like it would be right?
Yeah.
No. It's going to go over 5 and down 3. 1, 2, 3, 4, 5, and down 3. So this is going to be 5, -3. And then this guy looks like instead of over 3 and up 5, it's going to go over 5 and up 3. So about right there. If I drew that line right, it would be like that. So over 5, up 3. See why it pays to use graph paper? Okay, and then the last one, instead of 0, 8, it's going to be 8, 0. So what's happening with my x's and y's? What's happening with my X's and Y's? Yeah, they're just swapping. So all you have to do is reverse them. When it's reflected over X equals Y and Y equals X. So just flop them. So that's the mapping. This is what this mapping looks like. XY becomes YX. Okay? These are actually called inverse functions. If this was a function and this was a function, these would be inverse functions. So inverse functions are when you swap the X and Y. And the graphing of those inverse functions is just a reflection over Y equals X. Okay? That's about it. That's as complicated as it's going to get. It'll be weird if this was something besides Y equals X, but for now, we're just dealing with vertical reflections, horizontal reflections, and Y equals X reflections. So Y equals X are a lot easier than these guys too, because all you're doing is swapping the X and Y. Any questions?
Flack!